Welcome to Ask and Learn.
So here in this problem, we're going to have a diesel engine coupling with a railroad cart. And we have the speed of the engine, which is 5 kilometers per hour. And the car is at rest, 0 kilometers per hour. And we're also given that the mass of the engine is 4 times the mass of the car. And we want to calculate what is the final speed of the coupled engine and car. So first, let's calculate the momentum prior to the coupling. So the momentum is going to be, let's write it, momentum. It's going to be equal to the mass of the engine times the velocity of the engine plus the mass of the car times the velocity of the car. We know the car has 0 velocity, so we just say that this is 0. And then let's put an I over here as momentum initial. So then the initial momentum is going to be equal to the mass of the engine times speed of the engine, which is 5 kilometers per hour. So we don't know this momentum initial because we don't know what is the mass of the engine. But we were given in the problem that the mass of the engine is going to be equal to 4 times the mass of the car. So we could also substitute over here for 4 times mass of the car multiplied by 5. We get that the initial momentum is going to be 20 multiplied by the mass of the car. Now let's calculate the final momentum. Momentum final. And this is going to be equal to the mass of the car plus the mass of the engine, since they're coupled together, multiplied by the final velocity. So here again, we can substitute once more mass of the engine for 4 mass of the car. So 4 mass of the car plus mass of the car, we get 5 mass of the car times the final velocity. So then we equate the final momentum and the initial momentum, and then we get that 20 mass of the car is going to be equal to 5 mass of the car final velocity. We can cancel out the masses of the car over here, and then we just pass it down the 5 dividing over here, and we get that the final velocity of both the car and the engine together is going to be equal to 4 kilometers per hour.